In Chapter 10, we are now ready to conduct inferential tests in statistics. Okay. With hypothesis testing, we're going to be looking at different parameters. In 10.2, we're going to be looking how to conduct a hypothesis test for a population proportion. From the handout in 10.1, we learned that there are two types of hypotheses in statistics. One is called the null hypothesis. We denote that as H0. The other is the alternative hypothesis, and we denote that as H1. The null hypothesis, you could think of that as the assumed true value of the population until proven otherwise. Okay, and that's important right there, until proven otherwise. Because you as a researcher, if you believe that the true value of the population has changed, then you make your own claim, and that's the alternative hypothesis. The alternative hypothesis is your hypothesis. You're saying that you believe that the true value has changed, is less, or is greater than the population value in the null hypothesis. So what we're trying to do is we're trying to see if the null hypothesis, if that value is considered old data. And if it's old data, we would like to update it with our new data, which is the alternative hypothesis. Okay. So some things I do want you to note when it comes to creating these hypotheses, the H0 and H1. The null hypothesis will always have equal sign in this class. Okay. So when you're constructing the null hypothesis, be sure that we have equal to here. For the alternative, this is where the sign will vary. You'll either have not equal, less, or greater. Okay, and with those, the way we determine which symbol we use, that will depend on the keywords in the problem. Okay, so I'm going to show you the steps on how to conduct a hypothesis test, how to make a claim, and if you make a claim, you have to support it with evidence. I'll show you how to find evidence as well. And if we have enough evidence, we can reject the null hypothesis, the old claim. If we do not have enough evidence, we cannot reject that old claim. Okay, but the goal, again, with your claim, you are trying to show that the null hypothesis, the value is old data. We want to update it with the new data. So let me show you how to conduct a hypothesis test for a population proportion. So in example 1, a 2009 study found that 34% of teenagers text while driving. A recent study now claims that the proportion has changed. It was found that 353 out of 1,200 randomly selected teens had texted while driving. Does this suggest a change in the population proportion of teenagers texting while driving? Use alpha equals 0.05 level of significance. Okay, so the first step is to first form the null and alternative hypothesis. So we're going to set up the null and alternative. Okay, so for the null and the alternative, we first need to identify the parameter that's being used. And when we say parameter, we're either looking at proportion, mean, or standard deviation. Okay, so we're looking to identify one of those three in the problem. Okay, so if you notice, going into the problem here, we say a recent study now claims that the proportion. Okay, so we're dealing with proportion. So what we're going to do is we're going to set up proportion for both hypotheses. Next, we need to determine the symbol that each hypothesis uses. And from before, in this class, we will always use equal sign for the null hypothesis. The proportion is equal to some population value. We'll determine that in a bit. Now, for the alternative hypothesis, we need to identify keywords that can identify one of these three symbols. Okay, so whenever you see not equal to, typically you're looking for words like different, change. Those are going to be the keywords when you have not equal to, so we'll make a note. So not equal to, you want to look for keywords like different, change, Okay, those will be some of the keywords of interest for that symbol. For less than, keywords of interest will be something like decrease, okay, less than, smaller. Those are the type of keywords we're looking for to use the less than symbol. And for greater than, we're looking for keywords such as increase, greater, taller, anything that identifies with a greater than. Those are the keywords that we're looking for in the problem. So in this problem here, a recent study now claims that the proportion has changed. And notice that they're using this word changed a couple of times in the problem. Does this suggest a change? So change, we're going to associate that with not equal to. Okay. And then to finish the setup for step 1, we need to grab P naught. Now P naught, that's the value of the population presented in the problem. So here, notice in 2009, a study found that 34% of teenagers texted while driving. This 34% is the population value. So we're going to put 0.34 for both hypotheses. And notice how the hypothesis reads now. The null hypothesis states that the proportion of teenagers texting while driving equals 34%. And again, that's the assumed true value of the population until proven otherwise. And that's where we come in as a researcher, because if you think about 2009, that was a long time ago now, right? 2009, the first iPhones were just coming out, right? Androids were very new at the time as well. So maybe not that many teenagers had smartphones. But think about now, right? How many teenagers that are driving now have smartphones, right? So the researcher has reason to believe that the proportion of teenagers who text while driving has changed. So that's what the alternative is. You as a researcher are coming in and saying, I believe that the null hypothesis is outdated. Okay, so this is step 1. Set up your null and set up the alternative. Now step 2. For step 2, if we're claiming that the proportion of teenagers who text while drive has changed, then we need to gather evidence. We need to gather evidence to back up our claim. In this class, we're going to use the p-value method to gather evidence, okay? And that's where this alpha right here comes in, right here. This alpha equals to 0.05, that's where this comes in. Think about this alpha equal 0.05 as the probability of making a mistake in your conclusion, okay? So the alpha level is typically set by a supervising or managing team. They're usually the ones that set the alpha level. Suppose that we're given 5% room to make a mistake in our conclusion, okay? P-value, what this does is it describes the strength of evidence, okay? So here, this describes the strength of evidence. So if alpha is the room of error that we're given to make a mistake, we want p-value to be less than the room for error that we're given. Because if alpha is 0.05, and after we conduct our test is going to tell us we have that much room to make a mistake, or this probability of making a mistake, and if it's less than the room that we're given, this is considered strong evidence against the old claim, okay? And if it's strong evidence against the old claim, then we can reject the old claim. We can reject it. And that's the goal. We're coming in with our own claim, with the alternative hypothesis, and we're looking to support it with strong evidence. And if we have strong evidence, we will reject the claim, the null hypothesis. So how do we do this? This is where your calculator comes into play, okay? And with the calculator, whenever you're looking to find evidence for a proportion, Okay, so the setup. Okay, the setup to gather evidence for a population proportion. The calculator command that we're looking for of interest here is called 1prop z test. Okay, both the TI-83 and 84 will have the 1prop z test. So let me show you where to find it. So here I'm using the 83. You will go to stat, and we're going to go to test. We haven't gone there often this semester, but to finish off the course, we'll be using tests a lot. And I want you to look for 1prop z test. In the TI-83, that'll be number 5, 1prop z test. Okay, and let's hit enter. Now, the 1prop z test is going to ask us for a few things in order for us to gather evidence. Okay, so this p0 value right here, that's going to be the value in the hypothesis test. Okay, whenever you did step 1, okay, and you set up your hypotheses, p0 will be this value right here. Okay, so if you think p0, think h0, p0, h0. So we want 0.34 here. Okay. Now x and n, we've seen this before whenever we were talking about sample statistics. Here n is sample size, x is the number of individuals of interest in that sample, and notice here we're taking 353 out of 1200. And in inferential statistics, we use sample statistics to observe the behavior of a population, okay, with some confidence, right? That was chapter 9. So here, 353 are going to be the number of teenagers that texted while driving. So we're going to plug in 353 for X, the number of individuals of interest, out of 1200. Okay. And then here for that last symbol that we need, this is actually asking for the alternative hypothesis. What was your alternative hypothesis saying? We're going to take this symbol right here and just translate it and shift it over here. So we need to make sure that we're using the not equal sign in the calculator for it to know what hypothesis test we're conducting. So now we calculate. Okay, now we calculate. Now there's going to be two numbers of interest for MyMathLab. Okay, this Z number right here and this P number right here. In statistics, there's 3 ways to gather evidence. Okay, I'm showing you one way in this video, the more practical way. In a separate video at the end of the semester, I'll show the other ways. They're a little bit more difficult to obtain evidence for our test, but I'll show that towards the end of the semester. A more practical way to gather evidence is called p-value. But the homework assignment is going to ask for something called a test statistic. And when you're asked to find a test statistic, we're going to give the value into MyMathLab. We'll give it the value of the test statistic. Now, the calculator actually represents it as Z. It's actually supposed to be denoted as Z0. So for MyMathLab, I would like you to give it the value as is 3.35, rounded to however many places. The test statistic method is actually a separate way to gather evidence, and it's a difficult way to do it. But again, I'll show you in a separate video how to do that. The number of interest for us is called p-value. Okay, so p-value is going to be this value right here, 8.03. But then notice the calculator gives towards the end this e-4 thing, right? This e-4 thing. And let me show you how to handle that e-4. That's a scientific notation that the calculator gives us. And what that means is we're going to take this decimal place and move it to the left 4 times. So when I have 8.03, we're moving this decimal 1, 2, 3, and 4. then the gaps will fill in with zeros here. So our p-value is equal to 0.0008, okay? And at this step, we compare this p-value to the room for error that we were given compared to alpha, okay? So remember what alpha said. We were given 0.05 room to make a mistake in our conclusion. Okay, so this is alpha. P-value says, after conducting your test, our test is telling us we have about that much probability of making a mistake. Okay, if you notice, that's almost 0% chance of making a mistake. So if we're given 0.05% or 5% chance of making a mistake in our conclusion, our test after conducting it says, hold on, we have about a 0% chance of making a mistake. You are under the threshold of the alpha, and that's a very good thing. We want p-value to be less than alpha, okay? This is considered strong evidence, okay? And whenever you have strong evidence, then we reject the old claim. We reject the old claim. So what that means is this 2009 value of 34% was outdated. And we proved that it was outdated with our claim because we believed now that that percentage or proportion has changed. And it has because we have gathered enough evidence to do so. This p-value is the way of gathering evidence. Okay, so we reject the null hypothesis. So now we're ready for our conclusion. Step 3 is to conclude. And in my math lab, they'll phrase it in a very similar way. This is what we'll say. So, reject the null hypothesis. At alpha equals 0.05, we have enough evidence to conclude that the proportion of teenagers who text and drive has changed. Okay? And there's some things that I want you to know from this conclusion. Okay, this is a very typical format of the conclusion when it comes to hypothesis testing. So we first say whether we reject or do not reject the null hypothesis. Okay, so we reject the null hypothesis. We're going to state our alpha level. Okay, alpha equals 0.05. And then we're going to state whether or not we had enough evidence. Okay, so here we said we have enough evidence to conclude that the proportion of teens has changed. And then this is the last key bit right here. We're restating the alternative hypothesis when we say has changed. Okay, so this is the typical way to format a conclusion. We're going to practice example 2 following this video.